Super, thank you, Sally, and welcome everybody. It gives me great pleasure today to introduce Dr. Lauren Samet. Lauren is currently working as a zoo animal nutritionist at Chester Zoo in the UK. Prior to that, she's worked in other EAZA member collections in the same capacity, and she's consulted privately and worked with some commercial UK pet food manufacturers, formulating diets and gaining experience of the feed manufacturing process. Lauren actually completed her PhD in 2020. That was looking at the impact of calming nutraceuticals on animal behaviour. And prior to that, she'd done an MSc in animal welfare that was gained partly through a dissertation on UVB access for indoor housed dairy cows. Lauren is chair of the EAZA Zoo Nutrition Group, and she's currently finalising plans for their 2023 conference, which is being held in Riga in Latvia. We're going to pop some proper details into the chat for you to be able to register your interest for that as well. Lauren's interest in animal welfare is what led her to zoo nutrition. It's obviously a key aspect of zoo animal husbandry, and it allows lots of opportunities to promote positive welfare, good health and natural behaviours. So we're delighted to have you, Lauren. Thanks very much, and I'm going to hand over to you now.
Lovely, thanks Ellen, and thanks Sally. Right, so I'll kick off then. Thanks everyone for coming along. Let's see if my clicker works. Okay, so today, as you've probably all seen from registering and the description of the talk, I'll be running through vitamins in animal nutrition theory and zoo practice and their influence they have on health and welfare. I've got a picture here of the kind of like supplemental vitamins we're all used to seeing, but actually the vitamins we need, well, certainly wild animals need, available in nature through a balanced diet. So although we're used to seeing them like this, it's not to forget that actually we don't necessarily need to supplement if we're feeding a balanced diet and an appropriate diet for that species. So today I'll be running through all the vitamins, which is quite a lot to do in a short amount of time. Each of these vitamins could have its own webinar, but I just wanted to provide an overview of all of them and to give anyone new to the subject an idea of what they kind of take care of in the body, and what they link to within health and then in turn welfare as well for animals. And if you're, if you're not sure why you should care, then hopefully this will show you or give you reason for that. It's really important to recognise toxicity and deficiency in our animals. Obviously there's lots of variables that can be involved in that, but certainly diet is one thing to review if you notice poor health or disease in your species. And we're looking at focusing on the vitamins' influence on a variety of species. There's a lot of focus on species that have national the National Research Council's guidelines for them. So these were developed specifically to begin with production animals, and then following to horses, dogs and cats, companion animals, and there's also some for primates, laboratory animals as well, primates, rodents. But these are now, we're using these as kind of the foundation for our nutrition knowledge with our animals, and then building on what we know through these kind of large number evidence-based data to extrapolate that and use with our exotic species and our rarer species as well. All of the, or a lot of the information that I have today that hasn't been referenced directly to a paper is based on information that's provided in McDowell's 2008 book, so that's Vitamins for Animal and Human Nutrition, and yeah, that's like the foundation of what you might need to know there. And just, I'm trying to, where I can include any relevant details or things that might be interesting, especially some of the slides, if they're very heavy in theory, I've just tried to pick out some interesting pieces about each one. But as I say, it's a huge topic. Each one does its own role in the body. So by all means, don't think that this is the be all and end all of everything about them. If you don't find today's talk interesting, don't let that put you off learning more about them. As I say, it's really useful to be aware of our animals' health status and what might be affecting that. So hopefully everyone will find something of interest within this talk. So just to give a basic overview of what a vitamin is then, in case anyone's completely new to it. So it's an organic substance, essential in minute quantities to the nutrition of most animals and some plants too. They act especially as coenzymes and precursors for coenzymes in the regulation of the body's metabolic processes. It doesn't provide energy, they don't provide energy or serve as building units. That role is given to fats, proteins and carbohydrates. They're also present in natural foodstuffs or sometimes produced directly within the body as well. And we have the water-soluble vitamins. That's the vitamin B complex, vitamin C. These are less likely to cause toxicity because they're easily flushed out by the body through urine and feces. So they don't build up. They're much less likely to cause excess toxicity problems, but they're more unstable to light processing and storage. Then we've got the fat-soluble vitamins, vitamins A, D, E, and K. These can be stored in fat tissues in the liver. They remain for longer in the body. There's a greater risk of hypervitaminosis, so excess or toxicity, and deficiency can be related to fat malabsorption because they require fat for absorption. So yeah, just if you've got that kind of baseline understanding, it will help with the logical side of some of what I'll be talking about. There's tons of stuff like this on the internet if you're looking for kind of summaries of, you know, what they're called, what they do in the groups. You know, if you've got, I don't know, exams or you're studying vitamins or nutrition particularly, the water-soluble vitamins, you can gain them from many different types of foods. Fat-soluble vitamins, again, function sources, there's lots of data on that on the internet, so I'm not going to waste too much time on that, but you're looking at kind of your oily-based foods, vegetable oils, avocados, nuts. Yeah, that's just in the plant realm. And we'll kick off with vitamin C. So hopefully this is one that everyone's quite familiar with. Arguably one of the most known, thanks to the condition scurvy that sailors used to suffer from, why they used to take limes with them on boats to prevent it. And vitamin C is synthesized in almost all species except for ourselves, primates, guinea pigs and their relations. So for example, capybara, fish, fruit-eating bats, insects, and some bird species. So they're present in, synthesis is present in all non-passerine birds, but absent in some passerine species such as red-vented bulbul, for example. Because of this, dietary source is required. So these are the kind of key species, families that need that dietary source of vitamin C. And the reason that it's not synthesized is related to the enzyme 𝐸𝑔𝑢𝑙𝑎𝑛olactone oxidase, or much easier to pronounce GLOW for short. And that's essential for synthesis, but lost in several mammalian and avian lineages, which is why some animals are unable to create their own. And just an interesting fact is it took over 300 years from vitamin C's first discovery to medicine actually accepting that scurvy was caused by a nutritional deficiency. And we've come a long way in modern times, technology has evolved, but there's still, I really like this fact when I found it, because in zoo nutrition, there's things that we've kind of got evidence for, at least strong evidence for, but it's still not widespread and accepted. And it just shows that it takes time for human behaviour change and things to be picked up widely in culture. So I just thought I'd throw that in there. So in terms of vitamin C, its main function, or one of its main functions, is as an antioxidant. And so antioxidants, they stabilize highly reactive free radicals in the body, which helps maintain function and structural integrity of cells. I really like this little diagram because it kind of shows free radicals are these things that cause illness. They go around trying to steal electrons from healthy atoms in our body. So the healthy atoms involved with maintaining cells. Antioxidants come in and they actually donate one of their electrons to the free radicals. The free radicals no longer need to steal them from the healthy atoms, leaving them alone to be healthy. Without that, when there's few antioxidants, free radicals can do more damage because they start damaging cell structure, healthy atoms, and then things like cell structure. Oxidative stress, which is what free radicals can cause, is linked to aging, cancer, cardiovascular disease, and cataracts formation, amongst many other things in the body. So it's really important that we animals have a good supply of antioxidants in our diets. Vitamin C also has an immune role, so it's also known as ascorbic acid, and it has a stimulating effect on certain types of white blood cell and the formation of antibodies, and its ability to reduce circulating glucocorticoids, which is related to stress, and this can reduce white blood cell efficiency or efficacy as well. So really important there to support immune system and health. Collagen synthesis is another one. So if you take a joint supplement for any reason, you probably see that alongside your chondroitin and whatever else is in it, you'll have some vitamin C content too. And that's because it has a role in collagen, the fibrous intercellular protein, which is a component of the skin. It helps form strong, healthy connective tissues, bones and teeth. And in terms of general health, vitamin C can help regulate blood pressure. It can inhibit low density lipoprotein oxidation and increase high density lipoproteins. Again, that's probably a whole separate talk, but it's related to cholesterol metabolism. High density lipoproteins are good, low density are bad, so that's a positive thing. And it also helps in the formation of carnitine as well. And when we think of vitamin C, I think everyone always goes straight to citrus fruits, but just especially if you're practicing a fruit-free diet with some of your animals and want to minimize sugar in their diets, it's worth remembering that there's lots of other sources of vitamin C. So for example, parsley has 170 milligrams per 100 gram on an as-fed basis, and rose hips actually have 1,000 milligrams per 100 gram, which is insane. But yeah, so there's lots of other sources other than going straight to fruit and yeah, quite high sugar fruits. In terms of vitamin C deficiency, and this is where I've tried to include a range of species, in ruminants you might notice changes in oral cavity mucosa, around their muzzle, skin. You might see weight loss, failure to thrive if an animal just doesn't seem like it's doing that well. Infertility is sometimes occurs, and high chance of retained placenta as well during birth. Youngsters are particularly susceptible, especially in high stress environments, and that's because stress puts that pressure on vitamin C as an antioxidant. Therefore, its role as a nutrient doesn't necessarily get met, or there isn't enough to meet that both roles, if you see. In terms of swine, so the 𝘂𝘪𝘵𝗿𝘬 family, you can see weakness, fatigue, dyspnea, hemorrhages of skin and some other organs. In poultry, vitamin C is necessary for developing bones and eggshell quality. Horses, they can synthesize vitamin C, but again, stress such as that viral and bacterial infection can lower the serum status, so they might need additional supplementation in the diet. And in fish, you can see poor formation of connective tissues, disease such as fin erosion and issues with cartilage. And here on the right-hand side, you can see the two top right fish had a vitamin C deficiency when developing, whereas the bottom two didn't, and you can see how that's changed their, impacted their growth. In non-human primates, again, like us, scurvy is an issue. Squirrel monkeys appear most commonly affected when the diet doesn't provide enough. And again, you're seeing issues with teeth and gums there, to name just a few. Then we move on to the vitamin B complex, and this is made up of 8 compounds. So we've got like a few to go through for the B complex, but bear with me, we'll move on to the fat-soluble vitamins after that. So they're water soluble, as I mentioned at the start, which means they can be flushed away and there's low risk of toxicity. They often work alongside each other. So for example, B12 and B9 have a close relationship. And antagonists to their availability are often present in mouldy feeds, which is why we always, in terms of the practical side of feeding, would recommend feeding fresh foods that aren't past their expiry or appear or smell off. In terms of synthesis, a lot of these vitamins can be actually synthesized within the body. Ruminants, with their fantastically evolved gut, digestive tract and all the microflora that it contains, can produce nearly all of these vitamins if they're fed a healthy diet, if they're not in intensive systems, if their general overall health is good. Hindgut and foregut fermenters can produce most of them in suitable quantities, occasionally needing additional help with some of them. I'll go into more detail on that. And monogastric, so species like us, simple stomached, we can produce some, but sometimes we need additional dietary supplementation to support our needs. And I've just got a picture of brewer's yeast there because that is a fantastic nutritional source of the B complex vitamins. This because it wouldn't be a nutrition talk without mentioning fibre and sugar. We love it. Fibre is really important because it supports gut bacteria. It feeds gut bacteria, and if we have healthy populations of gut bacteria, we have a healthy animal. So the importance of managing and minimizing sugar intake can never be underestimated, because sugar actually impacts the pH in the gut, and that has a knock-on effect to impact the diversity of bacteria in the gut and their function, i.e. producing some of these vitamins. This has commonly been seen in equids and their susceptibility to laminitis and colic when fed high starch and sugar diets. Equids are hindgut fermenters. There's lots of other hindgut fermenters, foregut fermenters that follow that kind of basic same pattern. Sugar has been shown to contribute to inflammation because of that impact to gut bacteria. So again, that's why we always talk about high fibre, low sugar as being the best for an animal's diet and welfare. And for any of you that haven't ever looked at the Stevens and Hume 1998 paper. It's fantastic. It contains all these brilliant comparative anatomy and diagrams of lots of variety of species of animals. And everything I'm saying here is quite generic. I'm trying to talk about ruminants and monogastrics and things, but if you really want to get to grips with that and understand what that looks like and what that means from an animal on an anatomical level, I recommend going to this paper, and then you can start providing logic behind what I'm talking about here. And so then thiamine, B1, it's the first vitamin to be discovered. It's required as a cofactor in at least 5 life-sustaining enzymes in basic cellular metabolism, so really important. There's little deficiency risk for monogastric animals when ample quantities are provided in cereals or whole cereals or starchy root veg in the diet. It's very heat sensitive, so exposure in processing can lead to degradation, which can cause deficiency. Quite often you'll see it on the back of packet as an added nutrient because of that. And in ruminants, in non-intensive systems, as I say, internal synthesis from microflora meets an animal's needs. There's no worry there. In terms of deficiency, it can look like loss of appetite or loss of weight and weakness. Nervous disorders are also common, so muscle paralysis. Interestingly, the enzyme thiaminase, as the name suggests, works by breaking down the vitamin thiamine. So anything with a high concentrate of thiaminase poses a risk for thiamine deficiency. So thiaminase is found particularly in raw dead fish, so like sprats and herring, which I'm sure we all use in our zoos. Thiamine deficiency has been described in carnivores fed certain types of raw fish, as well as penguins, seals, dolphins. And this is why we use a fish eater tablet when providing animals with a largely fish-based diet. It's to prevent sort of certain deficiencies of vitamins, particularly thiamine, and there's some others too that I'll mention later. Thiaminase is also found in mouldy food, so again another reason not to feed mouldy foods, and some of this muscle paralysis you can see in a range of animals. Here we've got a reptile, so saltwater crocodile with a suspected thiamine deficiency, and that was found in the population. They weren't self-righting, they had slack jaws, they were floating at the top of water. It was noted the thiamine levels were low. Correction of this corrected that condition, and saying you can see that in birds and other species, mammalian species as well. Riboflavin then is the next one that's required for metabolism of all plants and animals. So every plant and animal contains B2. It can be difficult to be deficient when a good balanced diet is fed. Ruminal synthesis generates via the intestinal flora. So again, no concerns of deficiency there. Adult ruminants don't therefore require additional dietary supplementation, but young might if their rumen's still developing, as might swine and poultry. Liver in the body is the major site of storage, and dietary requirements really depend on a number of things. One is growth, the second is environment, but age, activity, health, other dietary components, as well as the rate of synthesis in the gut can also have a role on how much an animal might need. Deficiency can look like several things. It's rare, as I say, in ruminants and hindgut fermenters like rabbits and horses. Canines can exhibit low growth rates, anemia and corneal lesions. Felids can develop fatty livers, cataracts and alopecia. Non-human primates may present with freckled dermatitis or faulty grasping reflex. They might also have impaired vision and a scanty coat. And for birds, you may see this, what the images are on the right of curled toe paralysis. I've really lost how to say that today. Paralysis. So you can see how that looks in the feet, and that's can be present in several different species. And because I appreciate this is a lot of theory and I'm giving it to you at quite a fast rate, I've just put in a couple of palate cleanser slides where it's just a nice animal to look at. Take a deep breath, a sip of your tea, and then we'll go on to the next one. So niacin, B3, this is found in foods of plant and animal origin. The exact amounts required can be difficult to determine because it can be internally synthesized from the amino acid tryptophan. Deficiency can be seen alongside tryptophan deficiency. It's characterized by metabolic disorders of the skin and digestive system. Interestingly, ducks require twice the amount than chickens. Usually chickens is kind of our foundation kind of poultry example, but not in this instance. and that's because they cannot synthesize the niacin from tryptophan. So deficiency in ducklings can present as bowed legs or sometimes swollen hocks as well. Then we move on to pantothenic acid, B5. This is within bound forms within enzymes related to metabolism, such as coenzyme A or the acyl carrier protein, and it needs liberating from these enzymes for absorption to take place. Free B5 is then efficiently absorbed. It can be created by ruminal synthesis via intestinal flora. It occurs in a variety of foods. So the Greek for pantos means found everywhere, if that helps you remember that it's in lots of different things. Most species have dietary requirements between 5 and 15 milligrams per kilogram, and dietary fats and protein concentrations also influence body's requirements. In terms of deficiency, you might see reduced growth, lesions on skin, nervous system disorders. So you've got this example of goose stepping in this pig on the right-hand side, and that's where the stifle joints remain extended, so they can't bend them properly. There might be gut disturbance, reduced immune function, and impaired adrenal function as well. So some of these can be really hard to pinpoint the exact what it might be that an animal's deficient in, but a lot of these signs add up to an animal not thriving or not being quite right, and then it's about going and reviewing the diet and working out from there what it might be. Pyridoxine then, vitamin B6 is the next one. It's found in muscle meats, liver, vegetables, whole grains and nuts, so it's widely distributed in foods. Ruminants and hind and foregut fermenters find to synthesize this via their microbiome, and it has roles in protein metabolism, energy conversion, neural growth and development as well. The requirements depend on the species, obviously, age, physiological function, dietary components and intestinal flora, among some others. And deficiency can again look like retarded growth, dermatitis or issues with skin, convulsions, which is what we can see from this pig on the right, anemia and alopecia as well. So again, not necessarily, well, some of them more than others, not necessarily life-threatening states, but a failure to thrive that linked to diet. And then biotin. So this supports the enzyme that breaks down fat, protein and carbohydrates in the diet. You may be well aware of biotin, if you work with hoof stock. It's quite often mentioned in terms of hoof health. If you've worked with horses or any other hooved animals, you might have seen its use. It's commonly found in hoof supplements, and there is some evidence to suggest efficacy. In zoo animals, gaining evidence for large sample sizes is quite difficult because we don't keep animals in large numbers in zoos in captivity. But in horses, there's been good evidence to show that it supports increased hoof growth. And in dairy cow studies, where obviously maximizing production and reducing ill health is very profitable, there's been a lot of work done there too, which supports its use. There's been a good study by Lean and Raby they've conducted a meta-analysis of all the studies that exist and shown that biotin supplementation can improve hoof health and milk production, and although it's not significant, it looks like it is positively correlated with milk, fat and protein yields as well. In terms of elephants, so if you're an elephant keeper, you may or may not have experience with biotin. Supplementing elephants with biotin has been shown by Benz 2005 to improve or increase biotin blood concentrations compared to non-supplemented animals, but there's still lack of evidence as to what actual influence it has on elephant foot care. It's not actually been supported directly with that yet. That might be because there's lots of variables involved in elephant foot care. We know that substrate, environment, general husbandry of looking after the feet can be involved too. So the sort of jury's still out, but that might be another place you hear about it being used. And then folic acid B9 is the next one. It's well known as necessary in human nutrition for pregnant and lactating persons, and its requirements may also increase during growth. Requirements tend to decrease with age. Interestingly, cancer cells have a high folacin requirement. Therefore, drugs inhibiting folacin requirements requiring enzymes are often used in cancer chemotherapy. I just included that because it's, you know, it's part of the kind of molecular cell biology that vitamins play a part in, and I think that's just a really interesting fact, how you can actually fight disease with some of the knowing more about the vitamins as well. In animals, there's provision via dietary sources and intestinal bacterial synthesis. Adult ruminants, as usual with the B vitamins, have no need for dietary provision. Deficiency in poultry, swine, guinea pigs and primates has been seen if there's no dietary source. It's also linked to consuming mouldy grains with toxin-producing moulds, and loss can occur during cooking and processing too, as it's sensitive to heat and light. So that's worth thinking about if you're using highly processed foods that haven't had additional supplementation with folic acid. And then the final one, woohoo, we're nearly at the end of the B vitamins, is 𝗟𝑘𝗿𝑏𝑖𝑛, so B12. And this works in close association with the folacin-related reactions. It has very low requirements in the body. It's only synthesized naturally via microorganisms, not in plants. So again, it depends on a healthy gut bacteria population. Consequently, monogastric species living on plant-based diets tend to be more susceptible to deficiency, and it requires cobalt for its function. So the trace mineral cobalt is integral to its functioning. In terms of function, it has many roles in the metabolism. It's involved in the formation of proteins from amino acids, carb and fat metabolism, and also interrelation of other dietary nutrients. And deficiency in humans may result in pernicious anemia, if you've heard of that before, and in animals it can once again impact growth and can cause poor growth, weight loss, and deficiency can also be caused by a lack of cobalt in the diet. So all these vitamins, minerals are interlinked, hence the best approach to nutrition is a balanced diet all round. Okay, so moving on to the fat-soluble vitamins. Vitamin A, also known as retinol, is important for all animals. It has a deficiency and toxicity risk. Now we're moving on to the fat-soluble vitamins. There is a chance of excess because it's stored in the body. It's stored in the liver and fatty tissue and is supported in the transported in the lymphatic system, like all fats are. Vitamin A itself is not found in plants, but its precursors are, and its precursors are carotenoids. Hopefully, if you've got a zoo background, you will have heard of carotenoids. They play a functional role in many species coloration as well. There's over 750 isolated carotenoids in nature so far, but only 50 or 60 have biological activity. We have the provitamin A carotenoids, so they're converted to true vitamin A within intestinal walls, and these are beta-carotene, alpha-carotene, and beta-cryptoxanthin. And there's the non-provitamin A carotenoids. So these are not precursors to vitamin A, but you may hear about them again in terms of the coloration of birds or reptiles or amphibians. And these include lycopene, lutein, and zeaxanthin. And I should just say, sorry, all your vegetables, your fruits that are this orange-yellow colour, they will be a good source of carotenoids. The carotenoids are what make those vegetables that produce that colour. So deficiency, just like us, we're told to eat our carrots so we see in the dark. Deficiency of vitamin A can result in loss of vision, and this affects your retinas and the cells there, the rhodopsin cells that help you see in the dark. They're responsible for night vision. So this kind of deficiency can result in animals which would usually see well in the dark, like your cat here on the right, having very dilated pupils, trying to let as much light in as possible because they can't see so well at night. Bone growth defects are also a sign, as are defects in growth and differentiation of epithelial tissue. So you get keratinization. That's commonly seen in parrots and birds with a vitamin A deficiency. Again, you can see from this image on the right that this bird has this keratin buildup. You sometimes get kind of growths and lumps and bumps around the beak as well. It can also cause reproductive failure because it has so many roles within the body. And toxicity is approximately the upper safety limit is approximately 4 to 10 times the nutritional requirement for non-ruminant animals, so birds, fish, but approximately 30 times the requirements for ruminants, and that's likely to due to some microbial degradation taking place of the vitamin within the rumen. So that might be why you see levels on the back of bags vary so much between species. Hypervitaminosis, so too much of the vitamin, can lead to skeleton malformation, internal hemorrhage, reduced kidney liver function, and it can affect the metabolism of other fat-soluble vitamins as well, which has, as a knock-on side effect, can produce deficiency of those vitamins too. Just as an interesting side note, it's well known by, what used to be well known back in the day with sort of Arctic explorers and people from cultures that lived in those cold areas where polar bears, walruses existed. If you killed one to eat, you would never eat the liver because it would result in hypervitaminosis of vitamin A. And that's because their liver stores such a great amount of vitamin A. In terms of carotenoids, mentioned their importance in coloration earlier. So within captive amphibians, carotenoids may have a negligible, captive amphibians may have negligible access to carotenoids unless they're fed prey that's been freshly gut loaded with a carotenoid-rich diet. Captive reared 𝗟𝘂𝗿𝗄𝑗𝑗 frogs appear less colourful than wild frogs from the same origin. So you can see at the bottom left here, the difference between a frog pre-supplementation and post-supplementation is much greener. And that skin colour can be improved through carotenoid supplementation, but the key is to supplement during their critical period of growth, which is during post-metamorphic growth. And that's shown both in this species and in 𝗟𝘂𝗿𝗪𝘚 as well. And it's thought that dietary carotenoids also influence growth and fecundity in 𝗟𝘂𝗿𝗪𝘚 females. And I mentioned their impact on bird plumage as well. So here we have a bird that on the left, without supplementation. It's looking quite kind of brown and grey, but really in the wild, they would be looking much more yellow and green in their plumage. So this is from the xanthophyll pigments in the diet, and without those in the diet, the birds do not tend to colour up, their feathers don't colour up the same. This obviously has a knock-on effect to attracting mates, reproduction, and then conservation potentially if you're trying to breed these animals. You know, males, bright colours is a way of showing off their fitness and attracting a mate, so it's very important to them behaviourally as well as nutritionally. Then we'll move on to vitamin D. There's two main natural sources, and that's 𝗟𝘂𝗿𝗪𝘡, that's not so easy to say. Easier to say is vitamin D3, and that's the one that occurs in animals, and 𝗟𝘂𝗿𝗪𝘡, that's vitamin D2, which occurs mainly in plants. Functions of vitamin D, hopefully you've all again heard of this. It's also known as the sunshine vitamin because we can synthesize it within our skin, as can other animals. Vitamin D functions to help regulate calcium metabolism. Deficiency can cause metabolic bone disease, which you can see in this leopard gecko on the right. And apologies for sharing some of these pictures. I should have said at the start they are a bit upsetting because these are obviously all avoidable disease states, and they would cause an animal lots of pain and problems. Vitamin D helps elevate calcium and phosphorus levels in the blood serum to make it more bioavailable in the body. Many functions are yet to be determined. There's links in humans with its role in preventing kind of nervous disorders, like MS, for example. There's vitamin D receptors have been found in tissues unrelated to calcium metabolism. So it's thought to have many roles around the body. The science just hasn't caught up yet. In terms of deficiency, I've mentioned metabolic bone disease. Obviously, that doesn't just occur in reptiles, that can occur in any animal without the correct calcium and vitamin D balance, phosphorus balance in their body. It can also cause milk fever, known as parturient paresis in mammals. So it's particularly common in dairy cows because obviously their calcium regulation is so vital because of producing so much milk. They work on a very narrow parameter for calcium levels in the body because they give out so much within their milk. Rickets, that bow-legged signs, you can see in many different species birds as well. You notice if they've got a lack of vitamin D in their diet, they may start getting this developing bowed legs. And deficiency may also be seen as decreased appetite, digestive disturbance, weakness, in severe cases convulsion, but also soft shells and low breeding success in birds and reptiles. Because I'm short on time, I was going to run through the vitamin D3 pathway in the skin, but actually the uvguide.co.uk, which Frances Baines, who's an excellent expert on all things UVB and vitamin D, she co-runs this website, so I'd recommend you head over to that uvguide.co.uk and have a read if you want to know more about how the skin actually synthesizes vitamin D by the use of UVB light and pre-vitamin D3. There's also, to link to that, the Reptile and Amphibian Working Group UV tool, which is the document logging all the different types of spectrums of UVB needed in different types of reptilian and amphibian animal. Again, a really good resource if this is your particular interest in terms of subject area. Practically, what I would suggest in what this means is, because it's so important, vitamin D3 in our bodies and for our animals, to check your lamps with a calibrated meter regularly, because amounts of UVB light can decline very quickly. Test all the lamps, don't just test one and believe that they're all the same. Test them all because they will all be slightly different. Think about where you're positioning them as well, and how your animal's interacting with that light, whether it's basking or whether it's likely to bask in that area, whether it needs to bask or if it's actually needs it through other means of spending time in that environment as well. And to obviously observe your animal's behaviours with the lights and where they position themselves in relation to those. Vitamin D3 toxicity is very rare because the body has an inbuilt system for regulation, and again you can find out more about that from the UV Guide website. That's basically the pre-vitamin D3 can be broken down into intermediates to stop it going on to produce the completed vitamin. So it's much higher risk in terms of toxicity to overfeed vitamin D2. Overfeeding vitamin D2 may produce elevated blood calcium levels, lower blood phosphate. It might cause inflammation. It can also, because it messes with the calcium metabolism, start to calcify soft tissue. And you can see in this picture on the right here, these tiny specks of white within that non-bone tissue are actually calcium deposits, and obviously over time the greater they build up, the more of an issue you have with their function. Anorexia and weight loss can be an issue. Polyuria as well, that's seen in lots of different animals, but certainly in pet food sometimes you have issues with vitamin D toxicity, or vitamin D being provided in too greater levels when it's a fish-based pet food, because there will be a lot of kind of liver oil in that potentially, and toxicity has also been seen in some of our more exotic zoo species. So hypervitaminosis D in giant anteater and a large hairy armadillo was seen at a collection in the UK, and that appeared as weight loss, reduced appetite and vomiting. And actually analysis of the commercial insectivore diet revealed that there were amounts within the feed that were higher than on the data sheet, and that shows you why it's really important to not just believe what's on the bag, but do your own tests to support that if you suspect a vitamin or mineral issue.
Lauren, this is your 10-minute shout.
Okay, fab. I think I'm going to get there. Vitamin E then. Hopefully you're all still with me. It functions as a biological antioxidant, as we talked about this before, so really good for minimizing free radical damage. It also plays a role in blood clotting, protecting membrane structures and disease resistance. It also degrades during processing, so on back of bag you might see that there's a lot of vitamin E added, but actually what ends up within the animal might be less if that feed is being fed towards the end of its shelf life, because there'll be some loss through the food oxidizing. High levels of copper, iron, zinc and manganese can also affect its availability. There's 8 versions available, 4 tocopherols and 4 tocotrienols. Again, this is a huge subject, vitamin E. You could have, you know, a webinar itself just on this, and there's some great reviews out there if you're interested in learning more. It has a very close relationship with selenium, the trace element as well. Vitamin E is found naturally in fresh green plant material, vegetable oils, some cereal products, eggs and liver. Deficiency has been commonly recognised in zoo animals, so the reason we could provide a webinar on it is because it's been so well studied, because there's been all these problems with it in the past feeding zoo animals. and that appears to be especially within browsing or intermediate herbivores. The reason for this is thought to be that within browse there are lots of tannins. Tannins, as well as helping reduce the absorption of iron, can function as antioxidants. When you're reducing browse and reducing the tannins, you're leaning more on the vitamin E to act as an antioxidant rather than the tannins, and that's where it starts being used as an antioxidant rather than a vitamin within the body. So that's where deficiency may be being created. Again, more support for feeding more browse to our animals, that's what they're designed for. In terms of deficiency signs, they differ amongst species, but muscular dystrophy seems universal. So in ruminants and hoofstock, that might look like white muscle disease, which can also sometimes be caused by selenium deficiency. Retained placenta, muscle nerve degeneration is possible too. Lesser kudu have had particular study or focus on levels of vitamin E, because it's seen that they are particularly susceptible to low levels within the body, and actually in captivity they've had great difficulty with reproductive success. 𝘝𝑍𝐴 study showed that with additional vitamin E supplementation, injection, before and after birth, giving birth, I should just say, it helped with reproductive success, less chance of deficiency. In terms of swine, there is toxic liver dystrophy, infertility or reproductive issues. With birds, there can be seen inflammatory diseases of the skin, things like subcutaneous edema and crazy chick disease. In cats, foxes and mink, yellow fat disease, which includes a rise in white blood cells, so an impact on the immune system. And in primates, anemia and cardiomyopathy. In terms of how deficiency occurs, the amount of vitamin E required can vary depending on the levels of polyunsaturated fatty acids in the diet. It can also vary with selenium content, antioxidants and sulfur amino acids in the diet, but also stress, because as we know, stress can increase the need for antioxidants. Deficiency of vitamin E and selenium are linked to capture myopathy. That's why often if, before transport, certain animals, species that are susceptible to capture myopathy may be given an additional dose of vitamin E by vets to ensure that their body is ready metabolically to take on that additional stress load. And it can also, as I say, be caused by diets high in polyunsaturated fats, so cod liver oil, and that's because they inhibit absorption in the gut. Interestingly, medium chain triglycerides actually enhance absorption in the gut, so that's another thing to be aware of, or something maybe to feed alongside if you must feed PUFAs in the diet. And dietary fortification is needed to compensate for losses in processing. Toxicity can be related to it's relatively non-toxic compared to vitamin A and D because of its role as an antioxidant. So there's less to worry about there. And again, you'll often maybe see levels slightly higher in feeds. On to the last one then, I think we're going to make it. So vitamin K is the final one. It consists of a group of quinone compounds with anti-hemorrhagic effects. So it's synthesized by intestinal microflora, although it can be sourced via plants too. And the natural form is non-toxic even at high levels, so it's best ideally to be produced by microflora. Animals utilizing coprophagy, so for example rabbits, gain a source via the feces. It appears to be found in feces even when not present in the diet, showing the role of microflora in producing it. And it's also present in sun-cured alfalfa hay and fresh dark leafy vegetables as well. It has a role in blood clotting and coagulation, sometimes known as the coagulation vitamin, apparently. I've never called it that myself, but if that helps you remember. Deficiency can be impairment of this blood coagulation, which we saw on the previous slide with internal hemorrhaging there in the picture. Poultry, swine and giant anteaters are susceptible. It's thought that giant anteaters are susceptible because of the grains and lactose products which have traditionally been fed in inappropriate diets, meaning a disruption in their gut flora, meaning a disruption in their vitamin K production. And again, it can be brought on by poor gut health, the ingestion of antagonists. So for example, 𝘗𝘓𝑒𝑟𝑒, which is naturally found in spoiling sweet clover hay, and low provision in the diet if that's needed. Excess vitamin A and calcium can also impact their requirements. And then finally, my last couple of slides, Sally will be pleased to hear, just some practicalities. So without absorption, none of these vitamins going in make any difference. So it's not just about the amounts going into the animal, it's what the body is able to absorb and utilize that actually counts. Things that affect absorption include old age, which is why reviewing animal diets when they get to a geriatric age is important to ensure they're still getting all these nutrients they need. Parasitic load, both past and present, can make a difference. You can see in the images here on the right, parasites, worms essentially perforate intestinal walls, leaving them much less able to function properly. Stress can be an issue. Transit time through the gut, so the longer it takes to get through the gut, or the quicker it takes to go through the gut, I should say, the less time there is for absorption to take place, which again, why fibre is important. Other nutrients present, and that's sort of summarised on my next slide. Antibiotics, which impact gut flora, medication, just general health status, scar tissue or injury, and digestive efficiency as well. And obviously you can go back and look at the video and look at this in more detail, or you can find other summaries out there, but some of the vitamins and minerals affecting uptake of vitamin absorption are kind of summarized here. And some promote absorption and some do the opposite. In terms of where vitamins are absorbed, these are in a number of areas, and again, that's different. These areas look slightly different in every animal, so just a reminder on that. Degradation, also known as oxidation, is a factor and should be considered when you provide them. So UV light oxygen heat means you should always be storing your feeds in cooled up places, and we should be getting our feeds analysed in the lab to check concentrations. But sometimes there are inconsistencies in lab results too, so that's just another thing to be aware of. Don't believe it if it looks really unreasonable. Question whether it's been human error, equipment calibration issues, or differences in sample handling. And my final slide, the 10 things to take away from this for the practice of vitamins. If you're not a nutritionist but you're interested, check your expiry dates on feed. Obviously, keep within those expiry dates to avoid vitamin losses. Keep supplements out of sunlight in a cooled up cupboard ideally. Don't store frozen fish for longer than 3 to 6 months, and use a fish eater tablet if fish makes up the majority of the diet. Other than reptiles, think about other species that would receive high UVB levels in the wild, and so may benefit from them too in captivity, especially at this time of year, winter, and that includes ourselves. Review your vitamin E levels in diets, especially for large herbaceous browsers and species with diets high in polyunsaturated fatty acids. In terms of welfare indicators, don't just accept something being normal. If an animal doesn't look like it's well or thriving in captivity, don't just accept that. Get a welfare assessment, get a diet review, and check, do those checks and be thorough in whether it's anything that can be improved from a dietary point of view. Test the actual nutrient levels in diets. So use laboratory screening. It's expensive, but it's a preventative healthcare step that could save a lot in vets bills. A suitable diet overall is the best prevention for ill health. So we can accept fine, but we should be aiming for great. Please, if you're designing best practice guidelines, include vitamin requirements and guidelines within them. It makes our job so much easier. And if you're struggling with those, then speak to the ENG, contact myself or 𝘠𝘪𝘵𝑗𝑗, and we can ask the many experts within the ENG to help find those for you if you need them included. And finally, we're animals too. We always talk about animal welfare, but human welfare is also very important. So just if you feel tired all the time, make sure check your vitamin intake as well. Yeah, that's my takeaway. And there's my references. And thank you so much for listening if you've made it to the end.
Super, thanks so much, Lauren. That was really fantastic. We've had some great questions come in. So we've got a few sort of shy people at the moment, or with internet issues. So I'm gonna go through a couple of those. But if we get anybody that wants to speak up, then I'll put them on. So first question was, if we care for species that haven't got any information on their nutritional needs, you know, what should we do? What should we be doing? If we're using, related to that, if we're using model species, how do we know which is the best model species, and you know, how do we sort of make that decision?
Yeah, so this is where you know, nutrition is a science, and this is where you need research skills. So you're looking at the closest species. Again, I mentioned that Stevens and Hume reference with the comparative anatomy. You need to think about their natural feeding ecology, what you might know about them in the wild, what things they might eat in the wild can tell you perhaps what they look like inside if you don't know that information, or what they look like inside might be able to tell you about what they eat in the wild if you don't know that information. It can be difficult that for many things we do have close examples now, so it's not ideal, and it's not necessarily proven to be best, but for things like hind gut fermenters, we know horses and rabbits are hind gut fermenters, so between the two they're kind of quite extreme, but we can work on some assumptions that we'd use for them. There are more and more papers, again it's about doing the research. There are more and more papers in lots of different languages that are exploring these things in different species, and sometimes it's just the one sentence you need within like a 12-page paper it's the key to holding, you know, everything. But I think that would be my recommendation, and that's when, again, if you haven't got time to do that, and you're building the best practice guidelines, speak to the European Nutrition Group, because if it's something people are working with all the time, it's probably something they've come across already. Yeah, so recommended guidelines for similar species, think about natural diets, natural behaviours, comparative anatomy, and go from there. Yep,
super, thank you. We've just got one here. What, in your opinion, is one of the biggest sort of deficiencies in vitamins that we've got in zoo animals? What would be a main area for concern?
Well, I mean, certainly in the past, vitamin E has been a really big one, but because of that, lots of research has been done into that now. Talking reptiles, amphibians, birds, I would say vitamin D, but I think actually, although we feel like we're getting there now with UVB provision for these animals, and so preventing a lot of these metabolic disorders, MBD, things like that, we don't really know the impact that vitamin D3 has in our more exotic, larger species, like a giraffe. That must get really high levels of UVB in the wild, but how much are we providing it in the middle of the English winter? So it's not affecting them so much that they're sort of dropping dead from it, but it probably has a big impact that we're not so aware of, that might hold a key to just to better health. So yeah, I think some of those fat soluble vitamins, certainly.
Super, thank you. We've got a question from Chloe. I'm going to invite Chloe to unmute herself and ask this question directly.
Hi Lauren, can you hear me?
Yes.
Thanks for the talk, it was very interesting. And I had a question on vitamin E and 𝑠, because we usually do a one-shot injection of 𝑠 when we do interventions.
Mm-hmm.
And we're not sure with the data if it actually helps in the prevention of capsular myopathy, for example, or if it's kind of useless, and if we should continue doing it, or if it's not really worth it.
Yeah. And what species is that for?
We tend to do it of usually all the animals, mostly herbivores, or because they tend to run more in the enclosures. Usually dart carnivores in their inside lodgings, so they don't move as much. So mainly the animals that don't run in the enclosures.
Well, what I would say firstly is I'm not a vet, so I can't give veterinary advice. However, if you're feeding if you're feeding a diet rich in antioxidants for those animals that are browsers, if you can provide them with a decent amount of browse daily, and a baseline of vitamin E in the diet daily, that you may be able to top up or slightly even overfeed when you feel like coming up to a stressful point, that might help instead. Because there's lots of other factors, if you can, so in terms of it links really well to welfare actually, because stress obviously is a big factor in vitamin E efficacy in the body and uptake and use. So if you can reduce stress, so for example with the lesser kudu that have all the issues with reproduction, not only did they give them the extra vitamin injections in this study, but they also took them out of public display, they reduced footfall, they did lots of different kind of management routine, altered management routines slightly as well to reduce stress, which would then put less pressure on their vitamin E antioxidant needs. Does that make sense?
Yeah, definitely. Thanks.
I mean, sometimes it's unavoidable with things like transport, but certainly if you're feeding a good diet that's giving them plenty, and you can minimize stress in any way you can, that together that might help. It's a bit of an unknown though, and it probably varies with species. So it's probably better to rather than not if you are concerned with like morbidity or something like that from capture myopathy.
Okay, yeah, that makes sense. Thanks.
Thank you, Lauren. Another question here then. So it's a bit of a big question. We haven't got a nutritionist in our zoo. So this is on behalf of one of the people in the group. What would your advice be in terms of kind of arguing or pitching to the directors of the importance of it? You know, obviously alongside improving welfare, what do you think are the key things that really can only come with having a nutritionist in the zoo?
Yeah, so I think if you can, I don't know if you've got vets in your zoo, but if you can argue it from a preventative healthcare point of view, so sometimes nutritionists are placed within veterinary teams, you can save a lot of money if you can work out how much you're spending on vets bills, how many of those have been related to nutrition or poor nutrition. You could really counteract, you know, the cost of a nutritionist. Equally, you know, there's consultants now you can use if there's particular diets. You can, you know, if it comes down to cost, there's, because of dietary drift, animals leaving food or not eating food, there's ways you can save money actually using a nutritionist by making diets more efficient for animals. So sometimes people are feeding a lot more feed than they actually need to cover certain vitamins and minerals, but actually by using a different feed or a different supplement, you don't need to feed quite as much, depending on the species. If, for example, it's, you know, a herbivore needs lots more forage, but that is a really big question. It's something that I'm really passionate about, getting more nutritionists in zoos, because it's few and far between, and then knowledge dies if it's not shared. So it does need pushing more, and that's something that as the ENG we're looking at. We'd like to provide more argument for that. So I guess watch this space, but good luck. And feel free to contact me separately as well if you would like to talk about it further. Happy to support if you need more information.
Fabulous, thank you. So I've got a question, so hopefully it's not too stupid. Quick question. So you were saying that so the feed industry, like sometimes there's kind of mislabeling and well, not mislabeling, or maybe things are not exactly as they are on the packet. Yeah. Do you think there needs to be sort of more regulation of the feed industry as a whole? And sort of what's the best way for a zoo to easily kind of make those checks themselves to be able to check those nutrient levels? Yeah, well, firstly, I would always say if you're using a good reputable feed manufacturer, ask them the questions. Really, if they can't provide you information on the food that they sell to you, that they make a lot of money from you with, then you question, do you want to use them? Because that should be the minimum they can do about the foods they sell, right? With zoo feed is a really interesting one, and again, there's so much in this area that needs more development, but we kind of sit between pet foods, which are much more, they have like 𝘝𝑑𝐹, for example, which is like the European pet food regulation advisory kind of guidelines and board, and they cover everything from what you can say on packaging to what, you know, minimum maximum requirements for nutrients. And then you've got like cattle feed and production animal feed, which is much more, it's all designed around increasing production. So there's much less labeling because it's all about output rather than what, you know, as long as what's coming out is fine, it's not so much, you don't need quite as much detail as pet food. And we sit in the middle, and some feeds we use are more sort of the production animal feeds, and some feeds we use are more pet food feeds. But I feel like we need to be closer to the pet food in terms of our species are rare, they're valuable, like, you know, biodiversity, some of these animals we're working with, there's not many of them left. So we really need tighter control of it. And I would say push that back onto the manufacturer. And if they can't help you, ask them why. And if they, you know, if there's a real barrier, maybe look at a different manufacturer. Fabulous, thank you. We are bang on time, so I'm going to wrap things up before Sally shouts at either of us. Just to say thank you so much, Lauren, for coming along. It's been really fantastic, and thank you to everybody that's been and participated today, and thanks for some really great questions that are coming through. Apologies to anybody who we didn't get through with regards to questions, but if you've got any questions, then Lauren's details are on the screen, and if you just want to get in touch with her, then I'm sure you'll be able to help them. And details about the EAZA Nutrition Conference that are coming up are in the chat. There's not many spaces left for that, so just to flag that again, and to head along and sign up to that. Thanks, everybody.
Thank you.